Alright, so for continuing on with 4.2, alright, looking at a continuation from the end of the previous video, oblique asymptotes or slant asymptotes, right, describe end behavior, but it is neither vertical or horizontal, alright, so we're going to do a reminder of long division, okay, in a little bit. So the oblique asymptote it's really just a line, right? So we're going to look at this diagonal here, okay? And then create it also by the vertical asymptote. So in this next example, I started it for you already. So if you want to pause it here and write down these notes, or if you want to just take an observation. So I factored the numerator, okay, and nothing cancels out, all right, which is fine. The vertical asymptote is at x equals -1, right? Remember, the vertical asymptote always comes from the denominator, okay? And so I solve x plus 1, set it equal to 0, and I get -1. There is no horizontal asymptote because the degree is higher in the numerator, okay? Now, this is where I'm going to hopefully go over step by step on how to do polynomial long division, all right? So in this first slot here, right, I need to think what here times x is going to give me x squared, okay? That's what I'm trying to think about here, all right? So what times x is x squared? That's going to be x, all right? So that's going to be x squared, and I have to distribute to the 1, all right? So that's going to be plus x. One thing I need to also remember is when we do these long division problems, we always subtract these two lines, right? So x squared minus x squared, that's 0. Then I have -4x minus a positive x, that's going to be a -5x, all right? And then I'm going to drop down this 3, so I have plus 3. So now I'm thinking about, in this slot, right, what times x gives me a -5x, okay? So that's going to be -5, right? So -5x, I distribute -5 to the 1, that's -5. And don't forget to also, again, subtract these two lines, okay? So these cancel out, right? 3 minus a -5, that's going to be a plus, so that's 8, okay? Now that means this is your remainder, okay? So when we do these problems, the remainder it doesn't matter what the remainder is, okay? But take a look here. Up here we had x minus 5, right? And if you take a look, that's in the equation, or that's in the form of a line, right? Y equals mx plus b, okay? So your oblique asymptote is y equals x minus 5, right? Slope of 1, y-intercept at -5, right? So at -1, I have a vertical asymptote, okay? At -1, all right? At y equals x minus 5, so maybe somewhere around here, right? 1, 2, 3, 4, 5, -5, right? I know my slope is 1 and it's increasing, so I'm going to draw this a little bit better here. So I know that something like this, right? Now, if you want to be more specific, right, you can figure out some x-intercepts. You can figure out the y-intercept, right? Remember, for y-intercept, if you plug in 0 for x, right? If you plug in 0 for x, it looks like it's going to be at 3, right? So at 1, 2, 3. Okay. So what this graph generally kind of looks like is going to be something like this, right? And if there's a curve here in this region, right, then it's going to be diagonal over here like that. Okay. So hopefully that was kind of clear. I know that was kind of a slow process, but it does help going a little bit slower here. Okay. All right. So for this one, all right, there's a lot to look at here. All right. So I'm noticing that it is not factorable. All right. For the denominator, if I set this equal to 0, I get x equals negative 1/2. All right. So that's going to be my vertical asymptote. And you know, I'm actually going to put this over here to the right. Okay. So my vertical asymptote is negative 1/2. The horizontal asymptote, the degree is 1, right? X to the first, x to the first. So we said if the degree is the same, okay, then the horizontal asymptote is going to be the ratio of the leading coefficient, right? So in this case, that's going to be 2, y equals 2. All right. So what I'm going to do is I'm going to draw those in real quick. Okay, so here I drew in the vertical asymptote and horizontal asymptote. All right. Now the question is, how do you know where the curves go, right? Like, how do you know, does it go here and here maybe, right? Or does it go here and here, right? So the way we're going to make sure is that it asks for the intercepts, right? And so I'm going to start off by figuring out where's the y-intercept. Okay, so I know that I'm going to plug in 0 in for x. And when I do that, right, when I plug in 0 in for x, I get negative 3. Okay, so negative 3. So 0, negative 3 is maybe like down here, right? So here's my y-intercept. Okay. For the x-intercept, all right. So generally, look, so this y-intercept is here in this region right here, right? Okay. So that means the curve, it must be something like this. Whoa, that's not supposed to touch the. Sorry, this is very bad. So it must be something like this. Okay. If there's one over here in this region, then the other one is going to be in this region here. Okay. All right. If you want to be even more specific, what you can solve for is the x-intercept, right? Meaning your y is going to be equal to 0. All right. So what that means is you're going to set the function equal to 0, right? Now, so I want you to understand that first of all, okay? That you're setting the function equal to 0. And really, what you're going to do is, because, you know, algebraically, you're going to multiply by 2x plus 1 to get rid of this denominator, right? But 0 times 2x plus 1 is just going to be 0. And so kind of a shortcut is to just set the numerator equal to 0. All right. And you get x equals 3/4. Okay. And so the x-intercept here would be at 3/4, right? this is just to confirm and I guess reaffirm that the curve is in this region here. All right. The domain, okay. The domain would be all real numbers except for the vertical asymptote at -1/2, right? A couple ways to write it, I guess. We can put it in set notation, right? X is not equal to -1/2, right? You could, if you want, write it as an interval, so -∞ to -1/2, and then the union of -1/2 to infinity. And then the range is going to be y such that y is not equal to, what was it, 2. Okay. All right. You could also say -∞ to 2, and then the union of 2 to infinity. All right. Okay, for this one, you don't have to graph it, but it says to find all asymptote equations. All right. And so this one, the, let's see, I think this factors, right? On the bottom, this factors to x squared plus 3. Okay. And what you end up with is, if you solve for these, right, this one is going to be x equals 0. And this one, you get imaginary, but so there's only one vertical asymptote at x equals 0. All right. So we have a vertical asymptote at x equals 0. The horizontal asymptote, there is none, right? Because the degree in the numerator is larger than the degree in the denominator. So that means there's going to be, and it's bigger by 1. So I'm going to set up a long division setup here. All right, so here's my setup, and I want you to notice something, right? You know, inside for the numerator, right, you gotta put in the zeros, right, when it jumps and skips exponents. And so I wrote 3x to the 4th plus 0x to the 3rd, and so on and so on. Okay, so that's one thing I want you to be careful about. And in my first slot, right, I'm thinking, what times x to the 3rd will equal 3x to the 4th? Right, that's going to be 3x. So that's going to be 3x to the 4th. And then I distribute this to the 3x, so that's going to be plus 9x squared. Right? And don't forget to subtract the two lines. So these cancel out. Right? So there is no x cubed. So this is going to be -7x squared. Plus 0x minus 6, right? Okay, now, so now I'm thinking, what times x cubed is -7x squared? Well, that doesn't, we're done, because x squared is less than x to the 3rd, right? So all of this is actually your remainder. And remember, when we're trying to figure out the slant asymptote, we don't care what the remainder is, all right? So we're done. This is our slant asymptote, right? Your slant asymptote is always going to be y equals mx plus b form, okay? So your oblique asymptote or your slant asymptote here is y equals 3x, okay? And I'm sorry, I'm gonna have to make one more video for the other examples here.